Welcome back. This is Professor Ridge, and today's lesson is on section 3.6, Elimination using Matrices. So a matrix is a rectangular array of numbers, and just note matrices is plural. Okay, so matrices is just plural for matrix. So matrix is one array of numbers. So here's some examples. Okay, so we have three matrices here. The first one, and when we talk about matrices, we talk about the dimension. We always talk about rows. Number of rows by number of columns. So the dimension of a matrix. Oops, did I spell it right? Columns. So this one is a 3 by 4 matrix. Columns are up and down, rows are side to side. So we have, this is a 3 by 4 matrix. Okay, so we can use matrices as follows. So this example, write the following system of equations as a matrix. And what you do is we just keep track of the numbers, and we know we put the system in standard form where you have the x, y equals a constant. And what you do is you just write down the constants, the coefficients of x, coefficient of y, the constant. And for row 2, you're going to take equation 2, 1, 3, 0. And actually we call this an augmented matrix because this portion here is the coefficient matrix. And then we're going to attach to it the constants. Okay, so we call this an augmented matrix, but here we just refer to it as matrix. Okay, so we can use matrices to solve equations, and these are the rules of our game, this row equivalent operations. Each of the following row equivalent operation produces a row equivalent matrix. And so basically the rules that you can use is, the first thing is you can interchange any two rows. Interchange any two rows. The next one, you can multiply all the elements of a row by a non-zero constant. So basically that's like when we take an equation and multiply equation 2 by 3, and you multiply each term in that equation by 3. Well, for the matrix, you're going to multiply each element in the matrix in that row by whatever that number you choose. Okay, the next one is replacing a row with the sum of that row and a multiple of another row. So basically here, this is when we do the elimination technique. You can take two equations, multiply them by numbers, add them together to get a new equation. So this is the same idea here. You can take one of the rows, multiply it by any number you want, and add it to another row, and then you replace that row, one of the two rows that you just used, with the result of this operation. Alright, So it may be a little confusing now. I'll give you a couple examples and it'll all be clear, hopefully, at the end of this. Okay, so solve using matrices, and again we're going to use the row equivalent operations, and we say row operations for short. So first step is to write the matrix. So equation 1 becomes row 1. So 1, 3, 16. And equation 2 is row 2, 6, 1, and 11. So what I like to tell my classes is really matrices, solving using matrices with row operations, it's basically just bookkeeping. It's the same elimination method that we want to do, and we're just kind of keeping track of all the numbers. Okay, so our goal is we're going to use the row operations to get an equivalent matrix that it looks like the following. So for just two equations, two variables, just get that 0 there. That's what we're trying to go for. Okay, so basically it's like eliminating the x. So your question is, looking at just the x column, 1 and 6, what can you do to 1 and 6 to get a common denominator? So again, if I were asking you, as these were equations, what would you do to equation 1 and equation 2 to get rid of the x term? And hopefully you're saying, okay, you're going to multiply equation 1 by 6. So you get 6x, or negative 6, and be negative 18y equals negative 96. And equation 2, you're going to leave it alone. And then you would add it together. So this would be using the elimination method. So the x's go away, but it's really 0x. Then you get negative 17y. And that equals negative 85. So basically the row operations are, remember, rows are equations, or is this notation. That's another reason I have you do this notation, to prepare you for this. So this matrix solving with matrices, again, I like to think of it as just bookkeeping. What we're going to do is we're going to take negative 6 row 1 plus row 2, and we're going to replace row 2 with the result. So we're just doing the bookkeeping and writing this result. 0, negative 17, negative 85. And then the top row we're just going to leave there. Now, this book, so in college algebra we'd go further and we'd want to get where the 3 is, we'd want to try to get a 0 there next. But in this class, we're just introducing the concept of using matrices. So for a 2 by 2 system, 2 equations, 2 variables, all you need to do is get that 1, 0. Once you've done that, now convert it back to equations. So again, it's just the idea for this is to get you familiar with matrices more than anything. In college algebra, you would work further. So we're just kind of getting a feel for these things. So if I take that system and convert it back to equations, row 1 is 1x plus 3y equals 16, and row 2 is 0x, which just goes away, minus 17y equals negative 85. And now we're going to just solve like it was the elimination technique, because we eliminated x. We're going to solve this equation. So negative 17y divided by negative 17, negative 85 divided by negative 17. So y is 5. And then take the y equals 5 and substitute it in equation 1. Okay, so now I'm going to put row 1, x plus 3y, put the 5 for y equals 16, and solve it for x. And of course, we're going to write our solution as a point. X is 1, y is 5. Alright, let's do number 10, and we'll just kind of go more full speed here. So my first step is going to write it as a system, a matrix. And again, we're just kind of introducing this concept, so we're not going to solve it completely using matrices. We're just going to do that very first step. And my goal is I want to get this 8 to become a 0. And I can use interchange two rows. I can take a row, multiply it by any number that's not 0. Or I can take a multiple of one row. So I'm going to go negative 4 times row 1 and add it to row 2. So that's my notation. Now the book will write negative 4 row 1 plus row 2, put a little arrow, and you're going to replace row 2 with the result of this. Now again, this is bookkeeping. If you're having trouble, if you went over here on scratch work, negative 4 times row 1, that's negative 8, positive 4, negative 24. Row 2 is 8 to 0, and I'm going to add those together. So I'm going to add down the columns. That's 0, 6, negative 24, and I'm going to replace row 2 with the result here. So this is negative 4 row 1 plus row 2. And I'm going to replace my old row 2 with this result. I know a lot of students get confused with this section at first, but hopefully this pincast will help you. Okay, so that's it. We're done. So done with matrices. Okay. In college algebra, we would actually go further, but that'll be next semester. So for this class, now you're done with matrix. Convert it back to equations. So that's going to give you 2x minus y equals 6. And then the bottom one's going to give us 6y, equals negative 24. We're going to solve the bottom equation. So y equals negative 4. And then now we're going to find x. So we take the negative 4 and put it into row 1 equation, which is 2x minus a minus 4 equals 6. 2x plus 4. So subtract 4 from both sides. 2x equals 2. Divide both sides by 2. X equals 1. And now we're ready for the solution. And again, we can check first before we write the solution. So we're saying it's 1, negative 4. So 2 times 1 minus negative 4, does that equal 6? So 2 plus 4 is 6. Yes. 8 times 1 plus 2 times negative 4, does that equal 0? So 8 plus negative 8, check. Okay, so our solution is the point 1, negative 4. You can write it in your solution set, and you are done. That's a little overkill, but anyway, there you go. Alright, so let's try a little harder one now. Let's do a 3 equations, 3 variables. Okay, so again, our first step is we're going to write the matrix. So equation 1 becomes row 1. Equation 2 becomes row 2. Equation 3 becomes row 3. Now for 3 equations, 3 variables, this is our goal, what we want the matrix to look like. We want to have a 0 in the first position in the second row. And then on the third row, we want 2 zeros in the first two positions. So basically, we want this bottom triangle of zeros. So the idea is the bottom equation, our row is an equation with one variable, and we can solve it. The middle equation is an equation with two variables, so once we solve the bottom one, we can plug it into the middle one to get a second variable. And then once we have the two variables, we can plug it into the top equation to find the third one. So again, it's just bookkeeping. Now anytime you have a 1 in this first position, that makes it real easy to get zeros, because all I have to do is I have to take -2 row 1 times row 2, and that gets a 0 in that position. And for me, the way my notation works, which is a tiny bit different than the book, is when I write -2 row 1 plus row 2, this is referring to the matrix immediately preceding the matrix I'm writing down. And this tells me what I do to get that new row. So again, so let me do my scratch work over here. And the idea is you want to get good at this, that you don't write any of the scratch work down. You just punch it in your calculator as you go, or do it in your head as you go. But -2 row 1 would be -2 -4, 6. So I'm multiplying the top row in this matrix up here. I'm multiplying the top row by -2. So -2 times 1 is -2. -2 times 2 is -4. -3 times, or -2 times -3 is +6. -2 times 9 is -18. And then I'm going to do row 2, which is 2, -1, 2, -8. You're going to add down the columns. You're going to get a 0. That was my whole purpose of doing that, because my goal was to get that 0. -5, 8, -26, and I'm going to replace row 2 with this new result. And the way that I would do this in my head, or even maybe on a calculator, is I would do just columns, right? So I refer to the -2 row 1 plus row 2, and I would just kind of look at the x column first. And so I'll go -2 times 1 plus 2 equals 0, and write the 0 down. Then I'd go to the y column. -4 plus -1 is -5, and then I'd write it down. So that way I can kind of go without writing anything down. And this is just my bookkeeping. Alright, so now my next, so basically I get these two zeros. If there's a 1 there, I get two zeros in the same matrix. So now I'm going to go -3 row 1 plus row 3. And I'm going to, again, in scratch work or in my head, I'm going to go -1 times 3, or -3 times 1, which is -3. I'm going to add it to row 3, which is 3, and see I get a 0. So with a little practice, you don't need to write the scratch work down. Okay, so that's the x column. Then I go to the y column. -3 times row 1, -6, plus -1 is -7. So I'd write -7 down. Okay, now if you're writing it down, it's easier just to go ahead and multiply the whole row 1 by -3, which is -3, -6, +9, -27. Row 3 is 3, -1, -4, 3. Add down these columns, so we get 0, -7, 5, and 24, -24. And I'm going to replace my old row 3 with this result. So I got 0, negative 7, 5, negative 24. Okay, now my next step is I got to move, I want to get a 0 where this 7 is, and I can only use row 2 and row 3 with my row operations, because if I use row 1, I'm going to lose all the work I just did to get the zeros in the first column. So only using row 2 and row 3, get a 0 where that 7 is. So again, it's kind of like asking yourself what's the LCD for 5 and 7, and your answer should be 35. So I'm going to go negative 5 row 2, oh no, I'm going to go negative, sorry, I'm going to go negative 7 row 2 plus 5 row 1. So again, on my scratch work over here, so normally I would just do this on a scratch piece of paper, or with practice I do this on the fly and just write down the answer as I go. So negative 7 row 2 is 0, 35, negative 56. Okay, calculator for that one, 26 times 7, 182, negative times the negative is positive. Okay, and then I'm going to do 5 row 1. So this one I probably would do the scratch on it because the numbers are a little bit larger. So 0, negative 35, so I'm just multiplying by positive 5. 25, and that's negative 120. I'm going to add those together. 0, 0, that's what I was going for. That was the whole purpose of doing that. 56 negative plus 25, negative 31, and then 62. Now we're done with matrices. Convert them back to equations. And normally what I do is I don't write all 3 equations again. I just kind of, I start at the bottom and work my way up. So the bottom one is negative 31. Remember, this is x, y, z equals constant. So it's negative 31z equals 62. Solve that. So divide by negative 31. So z equals negative 2. Now so this is row 3. Now from row 2, see I'm going up. I know negative 5y plus 8z equals negative 26. So I'm going to substitute that into there. So I get negative 5y minus 16, because 8 times negative 2 equals negative 26, and solve it for y. So add 16. That looks like what, negative 10? This part where I miss having you in front of me, because you can always check my math as I go. Divide both sides by negative 5, 2. And then you're going to take row 1, which is 1x plus 2y minus 3z equals 9, and we're going to plug in the result from there from both of those. So now we know y is 2, z is negative 2. We're going to solve it for z. So we got x plus 4 equals 9. X plus 8. Oh, I'm sorry, we're going to solve it for x. So subtract 8. X equals 1. So we can check it. Oh, let me take that back. This was negative 3z. So this would be 6. That'd be 10. See what I mean about having you right here with me? You can catch me as I do it. Alright, but that's a good example to show you. So you just kind of, look over before you write your final answer. I can also check it by plugging it into all three equations. Negative 1 plus 2 times 2 minus 3 times negative 2. Does that equal 9? So I got negative 1 plus 4 plus 6. That equals 9. Check. 2 times negative 1 minus 2 plus 2z. Does that equal negative 8? So I get negative 2 minus 2 minus 4 is negative 8. Check. And usually if it works for the first two, it's going to work for the third one. But, technically I need to check all three. But for me, usually I say, okay, I believe it. Oh, negative 4z. Z is negative 2. Does that equal 3? So we got negative 3 minus 2 plus 8 equals 3. Yep. Alright, so now I'm ready to write my solution. It's x, y, and z. There you go. And we're done. So that's using matrices. Okay, so that concludes the lesson for 3.6, elimination using the matrices with row operations. Go to my math lab and complete the assignment there, and I'll see you next time.